So that's funny because this is about the same time we cover it. So the first core concept that we have is the squaring each side of an equation. If two expressions are equal, then their squares are equal also. It just makes sense. Now, steps, our solving steps. Step number one, especially with solving these radical equations. So the first main step is there one radical? If so, if there's only one of them, get it by itself. We don't want anything else with the radical. Now that doesn't mean anything about what's inside the radical. We just want that radical term by itself. Okay. If not, that's not how you spell if. If not, even them out. And for the most part, we're not going to deal with part B except for one section. I more put it in here so that we know if there's more than one radical, we need to even them out as best as possible. So if we have two radicals, we want one on either side. It is possible to solve it with them on the same side. It just gets a little tricky with square roots or radicals being multiplied together. We have a lot of different things going on. You're good? Make sure you have a note sheet. So as we look at this first one here, step one, is there one radical? Well, yes, we just have that square root of x. So the first thing we want to do is get it by itself. Well, currently the only thing with the square root is the 5. So we're going to subtract 5 from both sides. These will cancel, telling me that the square root of x, square root of x, is equal to 8. So at this point here, the radical is by itself. So we finished step one. We can go to step two. We want to put both sides to the nth power. What power do we want to put both sides to? 2. Because if I put the square root to the second power, I square it, well, the square root and the square would cancel, giving me x by itself. Now, at this point here, we're going to square the 8. And 8 squared is 64. There is no plus or minus with this. Because at this point here, we're saying what times itself is 8. Because we're trying to find the square root of x. What times itself gives me 8. So we only have one option, because really here we're saying is 64, because we'd solve it at this point. But we don't need a plus or minus when we square both sides. Third step. Once we finish squaring, simplifying stuff, we need to see, are there any radicals left? If so, repeat steps 1 and 2. We're going to go back through and keep doing steps 1 and 2 until we have no radicals left. But as I look at this here, there are no radicals left, so we can go on to step 4. And step 4 says solve for the variable. And really, we also need to check. Solve and check. Well, at this point here, x is by itself. It has been solved for. X is 64. And if we wanted to check this, all we've got to do is plug it back in. We want to see, is the square root of 64 plus 5 equal to 13? And really at this point here, we can plug that whole thing in. Second square root 64 plus 5 is 13. 13 is equal to 13. We're good. Part of the reason we need to check is because what's inside that radical, We can't take the square root. We can't take the even root of a negative number. So we got to make sure we don't have that. Questions on this first one? Let's look at the next one. 3 minus the square root of x equals 0. Is there one radical? Yes. So we need to get it by itself. What's the first thing we can do to get the radical by itself? Yeah, we can add the square root of x to both sides. It's very tempting because we could have subtracted 3 from both sides. Don't have to. It's a little bit nicer if we add the square root of x to both sides because this does get the square root by itself. It is positive, and we're good to go there. Now at this point here, the square root is indeed by itself. So we're going to put both sides to the nth power. And just like the first one, that nth power is 2. Left-hand side, the square root and square cancel, giving me x by itself. And 3 squared is 9. Since there are no radicals left, we can go on and solve. Lo and behold, it is solved, so x is equal to 9. And 3 minus the square root of 9 would be 3 minus 3, which lo and behold is 0, so it does check. 9. Questions on this here? This one's nice. This one's actually very nice. Square root of x equals 6. We only have one radical, so we need to get it by itself. It is by itself. So we can put both sides to the nth power. Square root and square cancel, telling me x is equal to 2. Not much else we have to do there. Yes. Questions on these here? I have a feeling you have it solved. 100. Get the radical by itself, telling us square root of x is equal to 10. Square both sides, or square both sides. X is equal to 100. I think we feel good with this here. You get 49. Yeah, because here it seems, because we'd minus 1 telling us negative square root of c is equal to negative 3. Divide by negative 1, square root of c is equal to 3. Square c is equal to 9. Works out fine. All right, let's get a little more involved. There's not much more to it, but its steps still hold true. First thing we have to do, since there is only one radical, we need to get it by itself. So the first thing I would do is subtract 3 from both sides, telling me 4 times the square root of x plus 2 is equal to 16. Then we would what? Divide both sides by 4, telling me the square root of x plus 2 is equal to 4. Is the radical by itself? Yes. So we're going to do what? Square both sides. Because at this point, we don't care so much about the x plus 2 yet. I can't do anything with it because of the square root. These would cancel, telling me that x plus 2 is equal to 16. No more radicals, so we don't have to repeat steps 1 and 2. But we do need to solve for x by subtracting 2, telling me x is equal to 14. Now, for the most part, we don't have to check this. This is going to work. 4 square root of 14 plus 2, what is it, plus What was our number? Doesn't it give us 19? That works. The main places we'll need to check is when the variable shows up outside the radical also. That's when we need to start making sure we check it. Here, we need to just get this radical by itself. Divide by 3. Tell me the square root of x plus 5 is equal to 4. Again, we're going to put both sides to the nth power, and that power is 2, so that the square root and square would cancel, telling me x plus 5 is equal to 16. Move the 5 to the other side, and we get x is 21, right? Shouldn't? 11? We have to subtract. Questions on this here? I feel like we feel comfortable with this. So really, I mean, we could do this. It's not much harder, not much more complex. We're still going to do the same steps. We're going to subtract 6 from both sides, telling me that the square root of 3w minus 9 is equal to 9. Other steps we need to do to get the radical by itself. So we're going to put both sides to the nth power, and that power is 2. Because the square root and square would cancel. Telling me 3w minus 9 is equal to 81. Add 9 to both sides, telling me 3w is equal to 90. W is 30. Questions on this here? Is there one radical? Even them out. They are evened out. I got one on either side, yes? So we're going to go straight to the second step. We're going to put both sides to the nth power. What power are we going to put both sides to? Second. And that's nice because on the left-hand side, the square root and square would cancel, leaving me with 2x minus 1. On the right-hand side, because it's just that radical, they would cancel. And really that worked for both sides because it was just that square root. We multiply by itself, the square root and square would cancel. Telling me that 2x minus 1 is equal to x plus 4. Are there any radicals left? Solve for x. Where are we going first? 10 minus 1 is 9. Square root of 9 is 3. 9, 3. Questions on this here? I don't think there was much need for explanation through that. Questions on this here? I threw this one in, and you can tell I re-edited it to get it to do what I wanted it to do. Still doesn't change what the solutions are, it just changes how its starting point is. Because our first main step, is there one radical? Yes. If so, even them out. So what would I need to do? Add the square root of 4x minus 7 to both sides. Now the reason I would do this, so I'm going to clear everything out, because if I jump straight into the first step of squaring both sides, the right-hand side would be 0, because 0 times itself is 0. However, the left-hand side, we're going to take the 3x plus 1 minus the 4x minus 7 and actually have to multiply it all the way out. Now, the square root of 3x plus 1 times square root of 3x plus 1 would be the square root of 3x plus 1 squared. Positive times a negative be a negative, then we've got 3x plus 1 times 4x minus 7 twice. One from here, 1 from there. 4x minus 7 times 4x minus 7, the negative makes positive. And we got square root of 4x minus 7 squared is equal to 0. I'm going to go on and simplify this out, because we'd have 12x squared minus 21x plus 4x is going to be negative 17x minus 7 Now, really, this is the only time I'm actually going to do it this way, because this is a lot of extra work for not a whole lot. Move those over. Funny enough, in the other video for 5.43, I would move the negative 2 over. Here, funny enough, we really don't have to, because we're squaring it and multiplying it by itself. If the negative 2 was being added to that radical, yes. Because the reason we don't have to is our power property of multiplication. I can apply it individually to both, which is just going to tell me I have 4 times. But just like before, we've got to distribute that whole thing back out. 49x squared, because that'd be 4284. Seventeen and 17 is 34. 34 and 34 is 68. All right. 6. 4. As long as I didn't, because I was jumping steps left and right, a whole lot going on here. Neither side do have addition or subtraction, so I don't actually have to distribute out. They're going to same answer, even amount. Even though I was skipping steps left and right on the first way through, I think it still made sense what we were doing. It was mainly just skipping a lot of the tedious work. 1/4. Yeah. Questions on this here? All right. Now we have a cubic instead of a square root. Let's see if the steps still hold true. Is there one radical? Yes, so get it by itself. It actually is. I'm going to rewrite it just so I have a little more space. So we're good with step 1, yes? We got the radical by itself, so we go to step 2, and step 2, as we had it written down, was said square both sides, yes? I think it did. What did it actually say? Put both sides to the nth power. But up to this point, really all we've done is square everything. This time I'm not going to square it. We're going to cube it. We're going to put it to the 3rd power because our root is 3. Cubed root, 3rd power will simplify, telling us that 5x minus 2 is equal to a big number. As 12 squared is 144. 12 cubed is 1728. Is there any radicals left? No. Solve. X is equal to 3 would make 15, so 23 would be 4, 30 would be 346. 1730. Especially with cubics, we're fine. Cubed root of 5 times 346 minus 2. If we wanted to, cubed root of 5 times 346 minus 2 is, lo and behold, 12. Any real different than what we've been doing? and that's it.